So the more content I got to add, I figure, you know what, maybe instead of trying to change some corporate culture, I thought maybe I should figure out how I can go out there. Because honestly, money must be the issue, but that seemed to be the only thing that companies it's like they couldn't offer me for you to change or anything. I don't know this experience. Like if they could offer me more money, so I figured, well, I'll just save some money, and I'm sure it's just as hard. So yeah, I figured out how to move on small amount for small as I could. Yeah, I've heard about people moving and like selling their. I heard about somebody who sold their house in Virginia. That they just bought a house down here. Yeah. They grew up in Austin. So like, this is a big.
Having so much fun with that musical chair. While we're waiting, since it's a small group, let me get everybody's name. Now we got Saul and we got Nina.
I'm Chris.
Hi, Chris and Tony.
Gavin.
Hi, Gavin.
Jean.
Jean. Chris, Gavin, Jean.
Brian.
Brian.
Andrew.
Andrew.
Alex.
Alex. Brian, Andrew. Alex.
Nathan.
Hi, Nathan. Awesome. I think you guys might have to remind me later on, but just now that we have names out there. Do you want to do this?
Yeah.
Cool. Who's Gavin? Yeah.
All right. Thanks everybody for coming. So this is KnoxData, monthly data science meetup. So we normally meet here every third Thursday of every month. On every first Thursday of every month, Gavin leads Knox Pi here in the same room. So every other week, you basically have Python related going on in the space here. So yeah, we generally kind of get a speaker to come. This time we've been really fortunate to have Tony Fast from Atlanta come up actually today to get to talk related to Jupyter notebooks. I'm really excited about that. So yeah, we'll have a talk. Afterwards, if people are interested, probably grab a beer. That's kind of it. But yeah, thanks for coming.
Super. Well, I didn't know this is a data science meetup. Are you officially affiliated with PyData?
Yeah.
Okay, excellent, excellent. So I came for a PyData meetup, not a data scientist meetup. I'm a failed data scientist, so don't listen to my data science stuff. I'm very, very, very bitter. Okay. So let's see. All right. So like since we've got a small group, I'm just gonna yell at you guys for a little bit, and well, I'll see what we're vibing with. But just kind of want to get a sort of a feel for people's experience with the notebook. Anybody use Jupyter notebooks? Awesome. Anybody use Jupyter Lab? Cool. Anybody here like not think the notebooks are serious? Anybody think they're a toy? Okay, I get that sometimes. I hope to prove to you guys that they are not a toy. I actually write software in the notebooks, like I write Python modules in the notebooks. I've written about 2,000 untitled notebooks at this point. That sounds weird to say. I probably sound like a weirdo, but they kind of make sense to me. I actually started the PyData Atlanta organization And I really like the PyData community because it's like welcoming to experts and it's welcoming to like newcomers. And like I've seen people come in who like we've had some people who started or in grad school, they were using the notebooks and they finished grad school using the same notebooks, which I think is like really cool. I see like the scientists are really finding ways to like use notebooks in a really useful way. And the need for science, so I changed the title of my talk. I changed the talk. You're still going to get some of the same business that abstract said, but I really want to talk about literacy today. I want to talk about like making notebooks to share with other people because that's what scientists really need to do. So in doing so, we're going to talk about software. We're going to talk about narrative. And before we get started, like we really, yeah, cool. All right, great. Yeah. So first of all, oh man, yeah, we're good. Sorry, the ordering was already screwed up. So first of all, Fernando Perez, he's the precedent for all of this. He started iPython, he's finishing his thesis, and who the hell wants to do that? Why don't you write a piece of open source software and it becomes like super successful, right? He has some like really great articles, and specifically one of the ones that catches my eye is this idea of literate computing. So literate computing is like a combination of interactive computing, but with a focus on, making stuff for humans. Like with enough acronyms, science becomes very non-human, and with enough code becomes very non-human. So what's the intersection of that? And he, in this article, he aligns it to data-driven journalism, which is just, this practice should make sense to everybody. We have some data, we filter it, we visualize it, and ultimately we tell a story. So underlying all of our computational literacy is this kind of nice filtering process. But in literate computing, while we're computing interactively and while we're working, we're not having a conversation with people. We're having a conversation with the computer. So the conversation with the computer is to manage data and compute and science. But when we're done computing, we're done interacting with our notebook, and maybe we spent like an hour or a day or a month working on the notebook. If you have that computer for 2 years, the amount of time that notebook spends in an interactive state versus its kind of static state is pretty fleeting. So what we're going to focus on today is kind of what can we do with notebooks and how can we prepare notebooks to have more preservatives in them? How can we make them last a little bit longer, right? So the idea of making literate documents and thinking about your audience when you're composing notebooks has some value. So the way that we're going to kind of align these discussions is we're going to talk about it in terms of literacy. Literacy is a recurring theme in, history, but also computer science. So this first section here, we're really focusing on the material pillar of literacy. We're going to talk about how materials and literacy help us with cognitive and social aspects of literacy. And then we're going to kind of jump into, we're going to do a section on cognitive literacy and then a section on social literacy. But in these pillars of literacy, I want us to really think about the separation, the fact that there is textual literacy and there is computational literacy. And the fact that the notebook has markdown and code means that it's a pretty great template for this concept. So who's heard of literate programming? Who's the first person to say literate programming? Who's the first person to bring it up? Who wrote the paper literate programming? Alan. Oh, see, you're way ahead of the curve because most people say Donald Knuth. It's actually Alan Perlis. Alan Perlis, he has this epigrams of programming are yeah. I gotta rework that question now. But anyway, these epigrams of programming are super fun. But the guy who's like really given credit for literate programming is Donald Knuth. So Donald Knuth wrote Tech, right? And his book is the book of the century, right? It's a 3-volume book, and only 2 of them are out. And scientists said it's a book of the century, which is crazy. It's unfinished, so that's how prolific it is. And in fact, he had to write Tech in a book because he needed a new way to do typesetting, right? And now, 40 years after he started working in tech, he has all of those documents that originally went into that book are still part of the test suite in LaTeX, right? There's 40 years of tests behind this stuff. And ultimately, Donald Knuth is the idea behind literate programming is write a literate program. Maybe people want to save their jobs, but like we kind of live in a in a climate now where we need other people to be able to use our code, specifically with open source. So, taking this idea of literate programming, in Fernando's blog post, he kind of talks about how it doesn't necessarily jive with interactive programming. So we bring this idea of interactive computing and literate programming together to get literate computing. So what that means is that when we're working on a notebook, we are writing narrative and we're writing code, and that's making data that we can share, we can push to GitHub, right? But while we're doing this, literate programming, or the interactive programming part is focusing on machine, and the literate programming part is focusing on people. And some of them can't hear, some of them can't see, some of them can't speak. You have all these different senses and stuff like that that are involved at the end of this. So how do we actually think about code as a computational essay for other folk? And one of the things, oftentimes we really focus on the computer programming side of things, but like I said, the state of compute is fleeting in the context of this as an essay. And we can kind of even look at all of the different paradigms that there are in programming, from imperative to declarative, where we have threaded and we have object-oriented and we have functional. When you're programming in the notebook and you're pulling in different toolboxes and visualization tools, you're really spanning all of these different programming paradigms. And in some way, we've really grayed the boundaries of how we program now. So we don't really have a style. And part of that style goes out the window because Python does so many different things. I'm not really good at programming, but Python lets me feel that way because I can visualize and explore data with pandas and Altair and Bokeh and Seaborn. I can do machine learning. I can do functional programming. I can do asynchronous programming. Asynchronous programming is really confusing, but the right abstraction lets you use it. So now, how important is the compute if I'm using other people's ideas? If all those ideas have been tested before, maybe they're really worth building off of. Numba's really cool. Y'all should check out Numba. And if Python doesn't satisfy your needs, then Jupyter is an abstraction, right? Like Jupyter was born from Python, then IPython, and then Jupyter. Jupyter is an amalgamation of Julia, Python, and R. Because the Julia community and the R community is like, we want this. We need this. So now this sort of language agnostic thing is emerged with Jupyter, and there are upwards of 100 different kernels available, and not all of these are documented. So you can go and look on the Jupyter wiki and see all of those guys. And recently, so these presentations, when I give them, I like to use old work as a foundation. And also really dig into some current events. And Fernando gave this talk 2 days ago about the architecture and evolution of Jupyter. So I really suggest looking at this sometime. But what's kind of interesting is that the ethical, social, and technical origins of Jupyter, they really align with Python. So, we're building off of, Jupyter is building off of ideas that are already popular. And okay, great. And we can even look back to a 1999 DARPA proposal that Guido had written for Python that talks about literacy being important now that everybody has compute. Like the mass ability to read and write code with literacy is really going to affect society. And we're seeing a lot of these Python sentiments being encapsulated in Jupyter and allowing us to do this. Maybe Python wasn't the thing, but the idea and the seed for it started there. And what's so important about literacy is that scientists suck at it. It's so hard to read research papers now. They're acronyms are the death of creativity in science, and it's just we really don't know what we're saying now, and the papers have become in some way illiterate. And we don't want to write in an illiterate program. And we can even look at this article that came out in the Atlantic about a week ago about how the scientific paper is elite. This pissed people off so much, but I really love I really wish this was flaming. Let's check this one out. I love this. Yeah, look at that. Isn't that fire? Love that. You bring it back to GeoCities days, right? But this paper is interesting because apparently Stephen Wolfram's a dick, or at least this guy tried to make it seem that way. It didn't have to be that way. It could have just been hey, open source is the reason that this is better. And community is the reason that this is better. But instead, they really focused on that guy. Yeah, anyway, Stephen Wolfram.
There was like 6 whole paragraphs in
Yeah.
that article about Stephen.
Yeah, yeah. He's like, IPython has the or Jupyter has the technology we had 10 years ago. Like, come on, man. But you know, your shit's good, but it stops somewhere. So like the thing that's really changing, like when I have to like describe myself as a scientist because I'm not a data scientist. I don't write research papers very well. Actually have a lot of learning disabilities and reading problems. So code and literate programming really mesh well for me. And new scientists have a difficult job. I mean, you know, our professors and our advisors have been faced for such a long time that they have an idea of what things should be, but they don't have how they're going to be, right? Like the need to publish and the need to share and all of these kind of intermediate results, they are an old idea, and you know, professors want to protect stuff. So literacy is really for the students and the modern scientists. So the modern scientist has to be concerned with replicability. I don't like saying that word, so I changed it to readability. Even though Gall's article is awesome, Gall is a contributor to scikit-learn or scikit-image. But the idea of readability is like, hey, can we, is this document literate enough that I can go and make this stuff, can I understand this? Reproducibility is, hey, does this thing work one for one, right? But that doesn't really have value to science. Like value wants to be reusable. So if it's reproducible and it's readable, then maybe we can take like little components of it, move them around, and now we can make something new. So reusability is where like the idea of cells and moving them around actually come into play. Can I take something from here and there and put it together and get something that's emergently better? So yeah, so this idea of reusability is ultimately the goal. Reproducibility is not important unless you're building packages. Reproducibility is very important in building packages. But if it's reproducible and you have good tests, now the potential to make it reusable is out there. Right? Without tests and without this foundational knowledge that works, how am I going to go and reuse this stuff as a scientist? And procedural literacy is it's augmented, it's not by definition literacy, it's a little bit more, and it's the idea, not only can I read this and understand this and reuse this, but now I can take it and reform it and do something new with it. So you get enough experience, and now you can start to craft different things and put them together and borrow knowledge from different places. So this first section here kind of goes through just some of what I think are the important materials to understand, like historically, and how like, you know, the notebook is affecting our cognitive abilities to share stuff. And then also like from a social standpoint, this reproducibility is not important. Reproducibility is something that we're talking about now, and I'm really interested in what we're going to be talking about in 2 years. When AI is in a competitive advantage, what are we going to do? And that's where reusability really becomes important. So now we're going to jump into I'm using Jupyter Lab here, by the way. You know, for just for you can't use the presentation mode that Notebook Classic has in here. So I've kind of like just thought about like how you lay this out a little bit differently. So right now we're in sync. Yeah.
I had a question since using Jupyter Lab a lot.
Yeah.
Have you run into an issue that Jupyter Lab is a lot slower to load notebooks than just the Jupyter notebooks?
No.
At all?
No. Jupyter Lab is fast as hell for me. It's I haven't had that issue.
It could be I'm just writing
too
much output.
That's possible. That's very possible. But also too, like everything in Jupyter Lab is like the new is always on the bleeding edge, right? So I think a new version just dropped like 2 or 3 days ago or something like that. So like even the new version of the notebook actually looks a lot more like Untitled something. The new version of the notebook actually has a whole different feel to it now. So this one's snappier. I think it's built off of the lab extensions or something like that. But yeah, I don't know. I haven't had that problem. And I do some horrible stuff to the notebook anyway.
Why is the file extension built IPython notebook instead of
because there's 2 million of them on GitHub, and who the hell would change it at this point? Yeah, I'm not. I mean, I think, you know, sometimes we have to bear specific technical debt. Sometimes we can shed them. Perhaps this is just one of those.
Extension.
Yeah. I mean, why not just make it JSON, right? Because they are JSON files. But anyway, yeah, cool. Okay, so, man, I love this image so much. Anybody know what this is here? This blackboard says, what I cannot create, I do not understand. Know how to solve every problem that has been solved. It's a scientist. All right.
Chris is a physicist.
Yeah.
Right? Gosh. He did quantum mechanics.
If you don't get it, it's fine, man.
Yeah.
So, you know, these notebooks that you're like, I don't want to show this to anybody because there's so much garbage at the end and I don't know if it runs through. The problem there is that you're not focusing on a concise unit of thought. You're thinking about a notebook. You're not thinking about notebooks, right? Like, if you think about notebooks, then you can start to take a unit of thought from one notebook and reuse it somewhere else. If you start to do if you take a notebook that works and you start adding shit to it and then it doesn't work, now you've got a bad test. So how do you start to isolate your first test, your hardest test to write, and make a second test and make it a third test? And that's really by focusing on a concise unit of thought. Creating a good introduction. Make your first cell a markdown cell. So if you need to present, now that becomes your title slide and your abstract, right? So, if you don't know, don't start with imports. Please don't start with imports. Please don't put 20 imports in front of your notebook and then tell me what's happening. Tell me what's going to happen and then import this stuff. Make these things literate because the compute doesn't matter. So y'all can go and read these things, but the one that like really stuck with me, restart and run all or it didn't happen. Okay. Every single one of my notebooks that has code in it will restart and run all. And if it doesn't, then what has happened to my test? It's failed. So out of the 100 notebooks that I have on my machine right now, or the 100 untitled notebooks, I'm pretty sure that 70 or 80% of them will restart and run all. So that means if I ever want to go back to an idea, I can go and search for my computer and build off of that. Or I can import that notebook and start building off of another idea. Concise units of thought. So, notebooks can, yes?
So I had a question kind of going on those guidelines up there. So I myself had a little bit of this problem where I found that using Jupyter notebooks to explore data and write a program is really useful. But as soon as it comes to packaging, it's like you have to rewrite it into a Python package. And I have a friend that he's written something pretty complicated in the Jupyter notebook and it solves this problem, but he wants to turn it into a Python package.
Great.
How do you go from this sort of...
I can tell you're doing my talk because I'm going to get to that.
Okay.
It's good when you're thinking ahead. Awesome. Yeah, we're going to talk about that, right? Shall I?
Oh yeah, go ahead.
Okay, so notebooks combine textual and computational literacy. So before I had that like crazy thing, if you think about your notebooks after the fact now, so I have 100 untitled notebooks on here. I can go and turn all of them into Markdown. I can turn all of them into HTML. I can go and turn all of them into Python, right? So what is the overlap between textual literacy, or between a script and a document? The overlap is that they both evaluate linearly. You don't read a book backwards. You don't read a book out of order unless it tells you to. And you don't write a program backwards or out of order. I feel like there's a situation where that's true. But for the most part,
choose your own adventure.
Yeah. There's like choose your own adventure notebooks or something. Yeah, like so if we just think about the symmetry of a computational essay as if it's a program, it evaluates linearly, and when it breaks, it stops. And if you're reading a document linearly and you don't understand it, it breaks and stops, right? So, that idea there means that if you're thinking about your document linearly in both contexts, you can export it as Python and potentially reuse it. The only thing that you need to do is, this is a weird thing, but you need to do it. Sometimes you have to use this condition. If name equals main, do something. So like, let's say we were to export this as a Python module, and it was named foo. Under name would be foo. But in this context here, it's main. It's always main. And what that means is you're basically writing Python backwards, right? Like in Python, you're going to write this huge module, and then you're going to go and work on your command line thing. Let's start with the command line because we're going to write APIs for people, and then we'll go and build out the Python stuff as it becomes necessary. So, yeah. And here's where we start to see some of those examples. So if name equals main, Jupyter convert to Markdown, -- execute. So -- execute is actually going to run it in a kernel and execute whatever it is linearly. So Now, this is another nice example of the multilingual aspect of notebooks because I'm using Dash directly inside Python and stuff like that. But yeah, so so this is one way to test your notebook. If it executes, if it doesn't execute, you'll get a failure. But if it does, yeah, you get it. It just finishes. Sick. So what happened? Oh, don't do that. Oh, sorry. I don't understand. Okay. So, Restart Run All promotes reusable textual and computational documents. Is the notebook sufficient to replicate? Is the notebook sufficient to replicate? It means that is it readable? If we can turn it into Markdown and HTML and we can share it with somebody, then potentially it becomes replicable. If a notebook is sufficient to reproduce, then we should be able to run it as a Python script. So now, if we can make a readable document, and a viewable document, potentially we can make reusable documents. Reusable notebooks are literate computational essays that can be replicated and reproduced. Who knows what essay means? That word? Just means to try. Right? Isn't that kind of nice and common to think about computational try? Right? Just gonna give this a go, you know, but like effectively a test is just a try, right? Like you don't know if it's gonna succeed or if it's gonna fail. So let's just write some computational tries. So now I want to talk a little bit about style. Because basically the only thing I'm saying to you guys as we leave here is write things linearly. Make sure when you leave your notebook session that you're not dangling stuff that's going to make it not evaluate. And if it's like screwing things up, you know, comment out the code cell or turn it into a markdown cell or something like that. But you know, make sure that this thing, make sure you don't frustrate yourself, you know, the next time you open this thing. Oh. Oh man. What I mean, like, it's crazy to think, like, we got that Atlanta article. Are you guys familiar with the LIGO project, the gravitational waves? Yeah. I didn't know if you were doing gravitational waves or just so.
I'm a little familiar with it just from watching YouTube videos.
Sure. So LIGO notebooks. This one here. So, do you guys know? Does anyone not know what the gravitational waves are? Cool. So gravitational waves are like the base of the universe, right? So when the Big Bang exploded, and some of these light-year-long waves started moving through the universe, and sometimes they pass through Earth. So if we've got enough sensors in Earth, and we can feel these gravitational waves moving through the different sensors, we can basically say that it's happening, right? So Min, who's a developer on Project Jupyter, had a notebook ready to analyze these waves. So as the gravitational waves are passing through Earth, he's using Binder, which is a collaborative way to compute, and 1,500 people are hacking on gravitational waves as they're moving through the universe, right? Like that's an amazing thought, right? Like the synchrony of the universe is just fabulous to think about. And you can check out these notebooks. You can compute on gravitational waves yourself. Super. But what's really happening is scientific computing is becoming part of popular culture. You know, the ability to compute faster, the ability to access data and share visualizations of it means that it's moving into our, you know, popular mind pretty often. You know, has anybody read Zen and the Art of Motorcycle Maintenance? Awesome. Yeah, Zen and the Art of Motorcycle Maintenance is a really great, like, popular philosophy book. It talks about like how things that are subjective become objective, and talks about method and madness, which I have tattooed on my hands. But there's a lot of deep science in philosophy. There's a lot of science in the philosophy, and you know, a TV scientist will say, "Oh, our thing failed." But the only failure that we have is not telling ourselves anything new, right? So, notebooks. Reproducibility does not tell you anything new. Reusability tells you new stuff. And like basically what's happening is all of our heroes are nerds now. You know, people want to work at Facebook and they want to work at Google. They just want to be friends with better nerds. Hello, you want to be friends with better nerds?
Yes.
Absolutely. Awesome. Hello. So one of the important things I think is it takes like, to be a cool nerd, you have to have a sense of identity, right? Like in a community, a successful nerd who gets funded, they really pick a domain, they pick something to talk about, right? So a sense of identity is something that's really important in these notebooks, right? So the things that you import give you a sense of identity. If you use pandas, if you use Dask, if you use tools, you can kind of say something about each of those people. But style in the notebook, like I said before, is really hard. So what can we do? We can start to like look at all these different other Zens. So we have Zen of the Art of Motorcycle Maintenance, which is a 400-page style guide. Or we can look at the Zen of Python. And what I love about this is in the context of literacy that we've been talking about, readability counts. The only thing that I disagree with here is namespaces are one honking great idea. Let's do more of those. Please don't. We already have pandas. We already have matplotlib. Please stop and just use other things. You know, that's why notebooks are nice. They can be untitled and still have value. They don't need a name to be of value. So beyond the Zen of Python, we even have the Zen of NumPy. We have the Zen of SymPy. So like what your identity in doing this work is finding things that are important to your communities from these different style guides and figuring out how to make them work better. And earlier we were talking about the value of open source and building software. You know, how do we apply? We can't directly apply open source software principles to better science, but we can take some of those best practices and use them to our benefit. Again, readability counts just keeps coming up time and time again. But build tools for others that you want to be built for you. I like to think that musicians who make good songs, they make songs that they wanted to hear, you know, or they thought that people needed to hear, right? So like that's what I like to think about when I'm making notebooks is what do people want to hear? What do people need to hear? Sometimes I like to think what's going to piss people off, but anyway, test ruthlessly. We don't do that in notebooks, but if you consider your notebook to be a test, you can start testing ruthlessly if you start making a lot of them. So, build for open source. In a notebook, if you're building Python modules and you're writing 20, 50, 100 lines of packages or of Python objects and classes and stuff like that, you're not building stuff for others, at least in the notebook. Like there's a place where that stuff belongs, but it's not necessarily in the notebook. So if we start to combine Paco's principles of a concise unit of thought and maybe 10 lines of code per cell, and then we start to marry it with this idea of how do we build better open source, then, or how do we design notebooks for open source, then potentially, we can do some better science. And Kenneth writes, he's quite a talented person. He has these really great essays. But, I like to think of notebooks as being a good hat. It's not everything. It's not your identity. But, like, it's a good hat, right? So be a good hat. Write notebooks for other people. Write notebooks that other people will want to put on their head. Or make T-shirts that other people want to wear on their body. By the way, I'm selling these if anybody wants to buy any. I've got boxes. I got a box of them with me. But, yeah, this is for all the scientists. Or future scientist. But yeah, be a good hat, please. So now we're kind of getting into the last part. We're doing all right. Okay. So I love this quote so much. The entire population of the world will be caught up in an infinite crescendo of online interactive debugging. Can you hear it? Can you hear the keys in Europe and the keys in Japan and everybody being pissed off and angry and drinking coffee? Does that sound lovely? But yeah, I mean, like at this point, everybody can share software, and we're really caught up in this idea of making the code work, but communicating it to other people. Like that's where there's another benefit, and that's where science differs from open source. Restart run all or didn't happen. Cool. So, has anybody ever seen the Motherwell demos? Anybody? Okay. I want you guys to watch an hour and 40 minutes of the world being flipped on the side of its head sometime. The Motherboard demos is the first demonstration of people using computers to work collaboratively. So Doug Engelbart's crew at Xerox PARC, they were the first people who used computers as a work medium, right? So in this demo, it's the first time that people are talking remotely on computers and getting shit done. It's really, really cool. And there's also a transcript on GitHub, which is nice. But I like the end of this quote where it says, so this characterizes the way that I can sit here and look at a clear blank piece of paper. That's the way I want to start my projects. So when you guys are working on your notebooks, do you spin out notebooks that you've already written, or do you start from blank? Blank. Blank? 50-50, yeah. Yeah, 50-50. Yeah, like you can get the same feeling of drawing and writing and, you know, ideation from a notebook because you start from blank. I find it so relaxing. Like, it's nothing. Because if I just saw one line of my code, I'm like, I hate you. I mean, I hate it. This becomes this big identity problem. I don't know if I work for myself or anybody else. But, you know, Motherboard demos is incredible, right? Like, it's so awesome to think that a scientist did shit for the first time, right? Yeah, they had to make a mouse, right? That's the first mouse. And in the Motherboard demos, that's when they shared it with people, right? So, I mean, this demonstration really changed the way that we communicate and really like was the seed for a lot of the complexity problems that we have in science right now. So, on the topic of open source, there's a new company called Untitled, and they recently did a survey about open source use in companies, and basically they're saying that 92% of applications that companies build have open source in them, right? And I mean, these results are kind of boring when you look at them on the aggregates. You're almost just like, of course, it has to be that way now, right? So, you know, in science, a lot of people are not using open source as effectively as they should. They're still writing their own numerical methods. So, encouraging people to use tools that have already been vetted by open source communities means that there's something more reliable in the future. And part of that reliability is really because we have package managers. So the package managers have aided the ability to get software, especially, you know, it's awesome to be able to download all the JavaScript packages because everybody loves programming JavaScript. Well, you know, Node really changed the world. Like that little piece of code that came out and being able to distribute Node packages has influenced Python and Kubernetes and Java and all these places. Anybody see Python?
You said, okay, open source packages can be vetted by the open source community. What's the best way to, I guess, determine that?
The number of tests that they have is successfully passed on Travis CI, Cafe, or Circle CI. So whenever, like, any big software project is going to have automated tests. And every time a branch is made and a pull request is made, those tests are going to be run right against it. So, you know, the log files that are contained in the open source testing environments are really the place where you can actually see some of that actually happening. So, you know, in our community, we always think about Conda, but really, Conda Forge is where the bleeding edge is happening. So, the Ruby community kind of has a packaging philosophy where it's like, let's stay on the most bleeding edge version. This way, people have less problems. And in Python, it was like, don't touch. Break. Don't install that, right? You know, we're really worried about how fragile our machines have become. So personally, I started always working on the bleeding edge of a Conda Forge release. Not if I'm building a piece of software that needs to be robust for experiments for a long period of time, but if I'm trying to do data analysis and I'm trying to do visualization and I'm trying to experiment with a new technique, I want to be working off the bleeding edge. Because if I'm working on something that's old, the potential for those tests to break or that API to break in the future is a little bit more likely. So I personally like working off of the bleeding edge. It's not for all projects, but you know, a majority of your projects you can totally get away with working off the bleeding edge of Pandas, the bleeding edge of Jupyter Lab. So from a community standpoint, like things like NViewer, so NViewer just kind of lets you sort of dump any, you know, notebook that's on the internet. What do y'all think about this? Notebook in my notebook. But yeah, anyway, Oh my God, it's so funny. I have another indie viewer link in there, and it goes right to that. Oh my God, this shit is so meta. Yeah. So you can do slides with indie. Let's just present off the other presentation. Right. So GitHub's like, y'all, for real, we can't keep sending you these notebooks, so we're just going to render them ourselves, right? And I really think that was a big bump in the innovation of the notebook and being able to start to share these things. So notebooks can export different formats for documentation, and they can be source code. And my buddy told me the other night when we were hanging out, a successful open source community did not exist without tests. You cannot quote me on this. No. So, but it's true, right? Like these tests are really valuable in us being able to have confidence. Like science is about trust, right? Like if a piece of technology is going to make it 100 years, it's going to make it 200 years. There's a sense of social trust and community trust and cultural trust with this. And right now, there's a lot of distrust in data right now, you know? So that's where it's really important to start thinking about being in front of other people and how your senses affect other people, because that's where trust is built. Like I personally, I go out of my way to meet the developers of the project. Like I'm not going to use this piece of software until I meet that guy. It's like seeing a band and like loving the band, and then like every once in a while this band would say you're a jerk. You're like, I hate this band, you know. Sometimes you have to make opinions that way. So this is really the crux. I didn't want this talk to be technical because there's nothing technical about this concept, right? It's actually very non-technical. But the one thing that I can say to you is you can test notebooks. Not only can you run them interactively, you don't have to do that manually all the time. You want automation at some point or another. But while you're interacting, you should have some tests. So if we were to take a notebook, like we have a test notebook on IMB, it's got some doc tests in it, and then we were to turn that into Python, we could run a doc test against it. Woo. Or we can run a unit test against it with doc test and unit test in there, right? So you can embed your test cases, right? So you write a bunch of functions, and then just put class test unit case there, and now, or class test case, and now you have actual tests that can be rerun. Or you can use PyTest IPyMB. So PyTest IPyMB is, anybody use PyTest? Yeah. Anybody do tests and not use PyTest in Python? Okay. If you want to start experimenting with tests and you haven't really done any of that before, PyTest is like really sweet. It removes a lot of the complications that users might find with testing, and it's just it's very literate. PyTest is very literate. So there's that. Cool. All right. So we're actually, I mean, this stuff here works. So we're running tests right now. Doc test complete, unit test complete, PyTest complete. So in PyTest, every cell is a test. You can put fixtures and stuff in there. There's also this crazy thing. Have you seen the robot kernel? So robot kernels is like behavioral-driven development or behavior-driven development testing platform. But again, it's super literate. It lets you kind of put the specific syntax in here, but the systems designers use it. It's kind of neat. A little bit nerdy. Anyway, so now one of the other things that I want to show you. So let's jump into some code here. So now, like I said, we just put a test case in our notebook, and now the only thing that you have to really know is that you have to run the test case with a unit test result. Okay. Otherwise, you don't get the outputs there, but you can run unit tests directly on the notebook if you give it a result runner. Now, this test actually has a docstring here. Okay, so let's go and say assert false, and now jump down to another cell. So assert false, and if name equals main, otherwise this will barf. Import doc test model. Good. Okay. So if name equals main, go and figure out everything that's in my namespace and run the doc test against it. So this is how you can build better documentation and better doc strings for your pals. So now we go and take this, swap it out. Bang. Oh, isn't that feeling just marvelous? Actually, if it gets there, we'll do print. Oh, never mind. Stop wasting time. Trophy. Times 10. Yeah! Heroic. Doc test your notebooks. But, right, if you export this as Python now and then you load it in somewhere, now you have a doc string, right? Now you know what you did, right? Like maybe your markdown isn't, maybe your narrative, your literacy isn't decoupled from the function as it used to be. So doc test model. All right. So if we want to use our notebooks at scale, we might only have a specific scope that we're considering. We can't consider what everybody might want to use, right? So that's where stuff like hypothesis comes in. And it's really great to find an API that's just like, it feels so good because it's just the right words. I don't have to go and look at the documentation all the time. So hypothesis gives us import, assume, given, and strategies. Given is a very common word in science, and so is assume, right? So it's really cool to be able to use these words. So now, Tony, you have to do something. Cool. So we've got hypothesis loaded in here, and so all right, let's do some things. Let me just print something here real quick. I want to show you guys a Jupyter Labby thing. Okay, so I'm going to right click here, and then I'm going to say create new view for output. And I don't understand why that launcher thing does that. I hate CSS. Yeah. Okay, so we just ripped out an output somewhere, I thought. Create new view for the output. Okay, cool. So now, all right, side by side here, we've got our new output. Where did it go? I'm back. Okay, so now if I run this with 13, you can see that it's being updated over here, right? Mm-hmm. So if I run F right now, what I said is that given the strategies, oh boy, come on. Sorry. Given the strategies of X being an integer and Y being text, let me go just, check some shit, right? If you guys had to test some text, what would be the first text that you tested?
Poo.
Awesome. Yeah, I go with poo, but that's because I like this little shit emoji. But you're never going to test emojis, right? So if I run F right now, I gave it a decorator that says @given this. Go and run this. So now what hypothesis has gone and done is it's going to create some strategies that have said, hey, let's try all these integers and let's try them in combination with all of this text, right? Anybody would have picked that one? No. But hypothesis and testing, like if you start to build this testing philosophy into your notebooks, actually provides you with the ability to test edge cases that you wouldn't have thought of before. So hypothesis is actually a way to kind of future-proof some of your code potentially. And underneath of the hood, hypothesis is supported by PyTest, and it's really just a unit test. So now let's break it, right? So what integer is false? What integer is false? What integer is not true? Great. Are there any others? Right. Okay, so assert X. Oh no, you guys, the hypothesis told me that was so. If I assert 0, it's false. It's not true. Well, what do we do? Assuming X is not equal to 0. Let's put our print back in here. So now our test passed, and we can put assumptions in there. We can say, hey, if this is a singularity in our equation, don't do that, right? So now with this really nice API that hypothesis provides, we can actually do hypothesis testing. And it's like kind of canonical, right? Cool. Check out hypothesis. It's the jam. So we also have, all right, let's get back to, all right, single document mode, presentation mode, party time. Okay. So beyond testing, some newer principles that are starting to move into more modern versions of Python are typing. I'm not going to show any of that because oftentimes that can confuse people. But good annotations should be hard to type. It should be hard to write. So there's tools like Monkey Type, which come from Instagram, which actually allow you to you can give it a function, A and B, and then you run a function against it, and then it returns you a typed function. Okay? So if you're working interactively, there's no point in assigning types ahead of time if you're just running a function against it, and you can infer the type. So, yeah, Monkey Type. All right. So to kind of like tie this all up, right? We're at the social pillar of literacy, and we're at the social segment in that pillar of literacy. But what's really happening is that we are in the throes of a culture shift. Our scientific communities are becoming more permeable because of the horizontals that open source software is providing us with. But it's not that we're eliminating the verticals, it's just that we're starting our science in different places now. And if you start from a notebook, from blank, each time you start, try and start in a better place. Try and start further ahead. Try and start to use tools that allow you to write less code but still do more. So that kind of brings us to science. Do your research, and that pays off in the end. It's very easy to program now. Don't do that. Read some shit. Because people wrote literate documents for you to do so. And that's why open source has been successful. And the success of open science is writing literate documents that people can also do the same. So, right, like, it's awesome. I love coming to these things because culture is an integral of communities over time and over space. If I didn't come here, I wouldn't have met new people. It's really cool. So Saul and I, we just started working together, like a month and a half ago or so. And we were on a meeting like 2 weeks ago. And we're just shooting the breeze before a meeting. And he's like, oh, I'm moving down to Knoxville. And it's like, who the hell moves to Knoxville? No offense, God. Like, oh shit, I'm going to Knoxville in a few weeks. And I was like, oh, where are you going? And I get to arrive like 2 days ago. So I get to come and meet my coworker, right? And I get to see some cool pieces of material science. God, that sample's so pretty. PyData is great, but here's what I want you guys to do. Next time that you guys have a PyData meeting, bring one of your friends, please. Bring new people to these things, because you all seem like a great group of folks. You're super engaged. Keep bringing people along, and this community will get better, and we will all start to have our own identity and our own styles, right? Like, that's how these communities emerge. And yeah, I don't know why I would put this there, but I think Jupyter is important. Anybody get that yet? I hope to see you all at JupyterCon. So JupyterCon, our second JupyterCon in New York this summer. And the other thing, this is maybe not for you, this is maybe for your new friends. Tell them that it's horseshit that you can learn programming in 30 minutes. Tell them that it's horseshit that you can learn programming in a week, a month. This takes a long time, right? This is a community thing, this is a culture thing, this is an identity thing, right? Like, I can't stop programming. I just need to do it, right? Like, it's become a compulsion to me. So, helping people understand that this is a community and this is a culture that wants that kind of stuff is a really great place to be. And at the end of this, I really like this one part here where, in terms of language choice, that doesn't really matter so much, but the bullets are great. Use your friends, code for your future friends, code for people that you haven't met yet. Code for people that when you talk to them, it's like, I needed that, and I would have never found it if I didn't have this conversation. Keep it simple, concise units of thought, think about your work as test, and play. Start from blank pieces of paper, think about this as doodling in class, think about this as just, passing some time and becoming a little bit more creative. But ultimately, play around, use the new technologies, try and figure out how to make your machines less fragile if you're scared to use new stuff, but try. And let's stop there. Cool. What's happening? Thank you.
This is more advanced talk that I was expecting. So I haven't used Jupyter before at all, but I've seen people use it. And
You're damn sure going to use it now, aren't you?
Did you mean that people in data aren't trusting each other as much?
I'll show you. Man, where did I put this? This is I hit a little Easter egg in here because it doesn't necessarily make me happy, but oh, it was when I said popular culture. Anybody remember when I did that one? It's the what? Yeah, it was the E. Which one was that? It was Persig. Sorry, I forgot. Yeah, it was the Zen in the Art of Motorcycle Maintenance one. Remember I put that one? Yeah, you're right. Your notebooks, kind of before it's got facelift. This one. Yeah, oops. We'll find it. No, so give it. I'm gonna. Yeah, maybe this is computational idea. Human. Cursing. Oh, never mind. West. Guinea. We'll go there. Scroll down. Come on. This is what I mean. This was the Channel 4 News television, talking about the Cambridge Analytica scandal. Now, we were talking about typing. What is the first thing that you see there? And right? It's heavy, right? Like we're having trouble trusting how people are using these technologies, right? So like people who are using our data at really, really large scales are really ignoring some of the human parts of it. So, that's why like this community and social part, like being able to talk about these things and, just understand some of the fears of it, like really help because, we are, hey, internet, you listening? We're being watched all the time and it's scary. But a lot of people don't understand to what degree they're putting their data out there. And I think in a lot of ways, people are having trust issues. You don't want to buy a pair of pants that rip the day you get them, right? You don't want to buy shoes where the soles fall off. But we walk into coffee shops and we see blue and we know it's Facebook and we see Snapchat and we see the green and we know that it's Snapchat. A lot of computer stuff has become fashion. And at a certain point you have to stop trusting big brands because it's a mind shift, right? Like I think that we can feel better about what we do with data if we start to understand our own data a little bit better and speak about trust within the communities. Because I'm personally scared. I deleted Facebook this week. What's kind of cool about that is that, or like the way I like to think about it, I deleted Facebook, and the first day I went to Facebook 13 times. So if I went there and I didn't sign in, but if I had gone there and I was signed in, and let's say I just went there generously 5 minutes at a time and just scroll through, that's an hour of my day out of there. And who's benefited? Not me, right? People who are generating the data, people who are selling ads, and people who are doing all that stuff, they're benefiting, right? So I also just really angry at some of what technology is doing. Sorry. Rant done. Any other questions? Yeah.
I had another question about Jupyter notebooks. So
sure.
Do you ever run into the problem like maybe one cell takes a really long time to run, or maybe requires, say, gigabytes of data?
What the fuck are you doing? What is your use case?
Well, I have some data sets that I need in order to create some plots.
Okay.
And say it's maybe